Test the hypothesis using the p-value approach. Be sure to verify the requirements of the test. H sub 0 is the population proportion equals 0.7 versus the alternative hypothesis of H sub 1, where the population proportion is greater than 0.7, where n is equal to 200, x is equal to 80, and alpha is equal to 0.1. So again, we're going to use one prop z-test. So stat, go over to test, and then pick one prop z-test. So p naught is what's in the alternative, the null in the alternative hypothesis. So this is 0.7, x is 80, n is 200, and then we want to pick greater than, so I already have that selected from the last problem, and then go down to calculate. Right, so since we're doing the p-value approach, we just are concerned about what p is from the calculator. So p is equal to 1, which is possible. So p is just a probability, so that number is always between 0 and 1. So be careful, you may get something that says e. So remember that's in scientific notation. You just want to convert it to an actual decimal. So in this case, we have a very high value here. So again, we're going to compare the p-value to alpha, and the p-value is greater than alpha, so we do not reject. Right? So let's state our conclusion here. So since the p-value is less than alpha, we reject, since the p-value is greater than alpha, we do not reject the null hypothesis. That means that there is insufficient evidence to conclude the alternative hypothesis that p is greater than 0.7. So let's say we change our n here to 100 instead. Let's see what happens. So let's change this to 100 and see what happens. So go back into test, and we're going to change our n to 100. So when we do that, we get a p-value now of 0.014, which rounds to 5 here. So 0.015. So now our p-value is less than alpha. So the p-value is less than alpha. So we reject the null hypothesis, and there is sufficient evidence to conclude the alternative. So you can see how that changes.